Greetings everybody, and in this video we'll be looking at a possible quadratic factoring shortcut. So this will be a special case when our leading coefficient just happens to be 1. That is, we have our regular quadratic, which looks like ax squared plus bx plus c, and that really is nothing more, and the problem we're going to be dealing with is just x squared plus bx plus c. So we'll start out recalling the guaranteed way that will work, and that is using our quadratic formula. Suppose we're given a quadratic x squared plus 25x plus 156, and we're asked to factor it. Our first step is going to be to compute the discriminant. Our discriminant then is b squared minus 4ac. So in this case, it's 25 squared minus 4 times 1 times 156, which just gives us a discriminant of 1. Taking the square root of the discriminant is really easy because we just have the square root of 1, which is against 1 again. Now, computing our roots from the quadratic formula, we have negative b plus the square root of the discriminant over 2a. And we have x is equal to negative b minus the square root of the discriminant over 2a. In this case, this is going to give us a minus 25 plus 1 over 2 times 1, which is going to give us one root of negative 12. And then for the other root, we have negative 25 minus 1 over 2 times 1, which is going to give us a negative 26 over 2, or a negative 13. Then, once we have our roots of x is equal to negative 12 and x is equal to negative 13, to get our factor, we just move the root to the other side of the equal sign, so that we have x plus 12 equal to 0, and so x plus 12 is our factor. Then we have x plus 13 is equal to 0, and x plus 13 is our factor. And so we know this quadratic will factor as x plus 12 times x plus 13. Doing a quick check and multiplying everything out, we can see that if we distribute everything, we have our x squared, x times 13 to give us 13x, 12 times x to give us our 12x, and 12 times 13 to give us 156. And sure enough, x squared, 12 plus 13 gives us 25, plus our 156, and our quadratic does expand exactly as we think that it should. So now to see what the shortcut might look like, we imagine that we already have a quadratic that's factored. So it looks like something like x plus q times x plus p. Well, if we multiply this out, distribute everything, then we have our x times x to give us x squared, x times p to give us px, q times x to give us qx, and last but not least, p times q. Now if we combine our like terms with the x, what we see that we have is our x squared plus p plus q times x plus pq. This gives us the roadmap for seeing our shortcut. For instance, in the last problem, we had x squared plus 25x plus 156. And so what we really needed then is that we need p times q to equal 156. So we need factors of 156. And the condition on those factors is that when we add them together, they give us 25. So our shortcut is really nothing more than this. We need factors of the constant that sum to the coefficient of x. And that is really what we're going to be looking for. Now, sometimes where this is a possible shortcut is how easy is it for us to find the factors of the constant. That's really the problem. If we can do it fairly easily, then this might give us a quick trick. If it's not easy to factor those numbers, then our shortcut really might not be a shortcut. So let's try our shortcut on this example. Suppose that we're given x squared plus 12x plus 32, and we're asked to factor this thing. Well, the idea in doing the shortcut is that we need factors of 32 which sum to 12. And remember, the 12 is coming from the coefficient of x. And so the question is, how can we do this? Well, if we just look at our factors of 32, one combination is 1 times 32, another one is 2 times 16, and a third is going to be 4 times 8. Well, if we look at our condition now that these things have to sum to 12, 1 plus 32, well, that's not 12. 2 plus 16, that ain't 12 either. But if we do 4 plus 8, now we do see we do get 12. And so what's the combination that works? X squared plus 12x plus 32 should factor as x plus 4 and x plus 8. So now in this example we have x squared minus 3x minus 10. Again, what do we need? We need factors of negative 10 that sum to negative 3. And so since we need a factor that's going to factors of a negative number, one of our factors will be positive, one of our factors will be negative. So if we're just looking at how we can factor negative 10, well, there's quite a few ways. In fact, we've got 4 of them. So 1 times negative 10, negative 1 times 10, 2 times negative 5, and 5 times a negative 2. And so if we just look at our condition now on the sums, well, 1 plus a negative 10 is giving us a negative 9. Nope, that is not going to be our negative 3. If we look at negative 1 plus 10, that gives us 9. Well, that's not negative 3. If we look at 2 plus a negative 5, that does give us a negative 3. And if we look at 5 plus a negative 2, that gives us 3, which that one is not a negative 3. So the one combination that we have that works is 2 and negative 5. And so what is our factorization? X squared minus 3x minus 10 then can be factored as x plus 2 times x minus 5. And now let's look at one more case where we have x squared minus 10x plus 21. So again, what are we looking for? We need factors of negative 21, or of positive 21, that sum to negative 10. Now here our coefficient for x is going to be negative 10. So how do we end up doing this? So before, when we were looking at possibility of factoring, we were really only looking at positive numbers. In our second case, we had some one positive, one negative. Now, because our constant is positive and our coefficient of x is negative, it means that our two terms are both going to have to be negative. In fact, if we look at all of the ways really to factor 21, we have 1 times 21, a negative 1 times a negative 21, 3 times 7, and a negative 3 times a negative 7. Well, looking at our sums, 1 plus 21 gives us 22. Nope, not negative 10. If we look at negative 1 plus a negative 21, we get a negative 22. Well, nope, that's not negative 10. If we look at 3 plus 7, that gives us 10, so we're getting close, but that is not negative 10. And finally, if we look at negative 3 plus a negative 7, now we land on negative 10. And so our combination that works is negative 3 and negative 7. And so our quadratic x squared minus 10x plus 21 ends up factoring as x minus 3 times x minus 7. So finally, one kind of important part of this possible shortcut is being able to see quickly when this shortcut is not going to work. Now, if we were given something like x squared plus 15x plus 40, if we go back to our trick and then say we need factors of 40 that sum to 15, well, if we go to look at all of those possible combinations, we have 1 times 40, which sums to 41, 2 times 20, which sums to 22, 4 times 10, which sums to 14, and 5 times 8, which sums to 13. None of these are going to work. So we have no combination that does it. Well, if we had a number that had a lot of factors, this could get really involved, only to get to the end to say nothing actually works. So what is the trick that can help us to do that? Well, the trick is coming back to our discriminant. If we look at our discriminant, b squared minus 4ac, what we have in this case is 15 squared minus 4 times 1 times 40, which gives us 65 for an answer. Now, where the discriminant will tell us this, if the discriminant is not a perfect square, the shortcut fails. And so one thing that we can do is to say, all right, well, 65 is not going to be one of our perfect squares. That we have 64 on one side, which is going to be 8 squared. We have 81 on the other side, which is 9 squared, and 65 in the middle, not a perfect square. And so in this case, we can see that our method is going to fail. And just go through trial and error, we can actually see nothing really does work. And so probably our first step always should be is this method going to work? Compute the discriminant, see if it's a perfect square, and then go from there. So suppose we're given x squared plus 20x plus 72, and we're asked to factor this one. Well, if we look at our discriminant, b squared minus 4ac, we've got 20 squared minus 4 times 72, which is going to give us 400 minus 288, which gives us 112. Now we can pretty easily see that this is not going to be a perfect square. We've got 10 squared, which gives us 100. We've got 11 squared, which gives us 121 on either side of 112, so this thing is not a perfect square. And so, rather than doing anything to try to factor this, we would say that it won't factor, or that it's irreducible. and we don't try any further. Now, if you wanted to convince yourself that that's true, try all of the factors of 72 and check to see that none of them add together to give you 20. And so, to end this video, it really comes down to the question of when does this actually come in handy? When can we really use this shortcut, and why are we even bothering to go through this? Well, we know that this shortcut is really going to work when the numbers happen to be easy. That means that we can factor the problem easy. We don't have too many possible factors that we need to check, and so it can go pretty quickly. So if the numbers are okay, then we can go ahead with this trick. So kind of when also does that happen, or when are the situations where this mainly comes up? Well, if you're in a standardized testing situation where you're taking the ACT and it becomes necessary to factor a quadratic quickly, chances are they're going to potentially give you numbers so that you can factor it quickly in your head with this simple trick. Does this happen really in the real world? A lot? Not really, no. So really outside of testing situations with standardized testing, or when you're doing homework that the problems are intentionally made easy to do this, that's where this trick comes in handy. It's a time-saving formula in those situations. That's really the extent of when we can use it, honestly. Coming back to factoring it guaranteed 100% of the time with the quadratic formula is really the most useful way of doing it, and this is a very niche situation where we can do things kind of easily when somebody arranges them for us to do that way. So I hope this has been kind of insightful. It's given you a little bit of a trick to help things out, to speed things up, and I will see you all next time. Take care.